target fault here. It's not a good idea. But usually not a problem. So the four chips, we have tended to put things on CCD4. It's our default position. It's usually working default. But so there are four of these. This is the guiding camera, by the way. There are four of these chips, and the way they're stored in the file, so it's a FITS file. The format of that FITS file is a multi-extension FITS file. So it means it has a primary extension, so HDU0 in Python speak, and then the CCD 1, 2, 3, and 4 data are in the subsequent extensions. Okay, so reading that into using, say, AstroPy FITS, you would open up the file and read extension 1, you get CCD1 in this way, and every extension has a header with important information. Among the things that are in that header is information about which parts of the chip is useful. So you need to look at headers. You don't need to do that in Python, you can do it on the command line. If you want to do it on the command line, there's a very nice little program called dfits, which is developed in ISO, which I like using. Where you have to say which extension you want, in this case minus X for extension 1, name of the file, and then you can say, okay, I want this particular quantity. And it will tell you what part should be used as bias region, to overscan region. And it will tell you the coordinates of that, which of course, since we're going to use Python, almost certainly will be swapped around. Trimsec is the illuminated part of the header. If you look at actually what the header says, it has a comment and it says illuminated pixels, which should give you a hint. So this is the bit that has useful science data. The bits that's outside is the stuff that's biased. Okay, so this is something you will do yourself. It's also useful to look at images. So if you will do DS9, you can open up one extension. You do that in the command line Unix. You most certainly would want to use these escapes, otherwise you don't get any result. Or you can open up all extensions in one go by using multi-frame as an option. So those are the things you should explore. And looking around using these techniques here is also useful. Okay, these don't display as nicely as the images you got for problem set 1, for instance. Okay? They look less good. Okay, so what's the task for today? Well, as I said, I want to talk, so Rudolf and I will be talking to each of the groups in a numerical order. I had no reason to do otherwise. Maybe I should have started 8, 7, 6 this time, but I'm not very inventive clearly. For the rest of you, the idea is that you really should start to do data reduction and try things out. So all this text is, by the way, on the Blackboard side, so you don't need to write things down. So the data from last year, just a few data files from one night. Okay, this is because they take a bit of space. It's not very much. They're stored here. There's a file called run1, which contains all the information on the files in the folder. It also contains the information on lots of files that are not in the folder, because I didn't copy them there. So you should have a look and see what the different data sets are. There's some simple things you also should check. Check whether the flats or biases are the same or differ between the different CCDs. Okay? Can you just make one bias frame and use that for all the CCDs? Or do you need to make one for each CCD? What about the flats? It's the same thing. I made it easy for you because I only copied things out in one filter, but you should check that too. And then the next task is basically to write a small Python script to create a master bias and to look at these simple questions and create a master flat and then apply the bias and flats to the science exposure that's there. So that looks pretty straightforward, simple, probably going to be done in 10 minutes. Or done.
Or we're going to take 2
so
hours.
it's none of this is particularly hard, okay, in principle, when you've done it before. So this just takes a bit of time to get used to these things, so I'm sure this is going to be a little bit fiddly for people to do that. But there's nothing intrinsically hard in it, so that's worth knowing. So I wanted to close, before we go up, I wanted to just make one comment about something that's useful to know. I've changed Blackboard for this, but my internet connection got cut down again, as usual. Just involve myself in. So, every time I log into the network here, it tells me to register my computer. And I've registered it 50 times. It still tells me that I'm registering it.
I know why.
But it tells me all the time that I've successfully completed the registration procedure, and processing of my registration may take a couple of minutes.
Is this the UL STRW Lyon?
That's the one. Because it works really well when it works. Just decided not to work.
MSC address each time. I think
Mine is permanent.
and you're probably not switching your MSC address.
No, it's okay.
Oh, you set it up. You might want to tell how, because that's probably going to save you
Something else working. Okay, so what I wanted to show you is actually mostly relevant for people with Macs. But I thought this was still a very useful thing to know about. So this is a program called iObserve, which I used to not suggest for people because it is a paid program. But it was released just a short time ago. It was released for free for everybody. Just I'm using for those of us who paid for it. Anyway, this is a very useful little program for exploring things. So if you want to observe an exoplanet, for instance, you can go through here and let's see what's chosen. Say you wanted to observe one particular, let me go Kepler. Surprisingly enough, quite a few.
10.8 en het 10.9 en trap.
Why is this now deciding to be so
not really scalable. That's
okay, so let me just try Kepler 126. Want to observe that? And it will automatically give me the observability of that particular target. Not very good in this case. You can put in small bodies if you want to observe asteroids or other things. Here's another planet, a WISE planet, another exoplanet. In this case, you can now see quite well. This is the observability on the 6th of February, and you can adjust the days you want to use. You can have a list of multiple exposures, and there's plenty of other pieces of information here. You can get times that an object is visible, and you can also create finding charts automatically for all the objects. So this is now freely available from the. So for those of you who have a Mac, it's actually not a bad thing to have on your computer.
10.9 and up though.
10.9 and up, that's true.
Alas.
That's true. Yeah. I think there are older versions, but they might not be free. So I'm going to use this at the telescope to organize our observing. So these will be. You can also enter in your own object. Say you want to observe M51. We'll didn't find any. Interesting. That's interesting. It doesn't exist then. Okay. So we have M51. So it is also useful later for finding nice targets and running out of targets. Okay, so that was the main things of today. Does anyone about the data reduction, the planning for the trip. Because for each of you, now that we meet, discuss the proposals, I guess you'll have plenty of questions. I certainly have a few. So we move on to the fourth floor, and we'll meet in the group on the fourth floor. And we'll see
Let go.